So in the previous class, we did VLAN. And as I said, we saw access port, auto, trunk. Now, before we get into this inter-VLAN routing, which we also did a little bit in the previous class, like we had VLAN 10, another VLAN 10 on this switch, and when VLAN 10, 20, another VLAN 20 on this switch. And then to do routing, we connected to a router, one link for VLAN 10, another link for VLAN 20, and also for layer 2 communication, we had a trunk link. So this F4 will be used whenever you are pinging same VLAN members on the other switch. But that link cannot do routing for us. So if someone wants to route, we saw that we need a router support. Connecting a router like this is a poor design. Why? I'll explain after some time. But before we go into this inter-VLAN routing topic, I would like to finish something which is pending. You see, for the trunk, there is a negotiation protocol. The trunk comes up after negotiation. Negotiating with whom? Negotiating with other end of the wire. Why there is need for negotiation? All this we are going to see now. We know a trunk port is a port that is part of all VLANs. Trunk port is a port that can carry multiple VLAN traffic. So we have switch, we have two switches, and we have a wire connected. And let's say this is F0/4. This is F0/15. Now this port by default is auto. Administratively auto. We call it as administratively. Is it correct? No. Is it auto administratively? Correct. Just I was trying to confuse you. Administratively auto. Operationally, it is an axis. Same on the other side. So this link cannot become a trunk link if you leave it default. So what we do, we can go to both the side and create and configure trunk. When you say administratively, when you when you configure trunk, operationally there is no other option. This port F04 will become trunk. Trunk. Now this trunking is not because of negotiation. It is because of we turning on. This is what called as on mode. We turned on the trunk. Is it trunking because of someone negotiating with this port? No. We turned on. Whereas this port you fail to turn on, but it will also be trunking. How is that possible? Because administratively by default it will be auto. Because it is auto, if switch 1 comes and negotiates, saying, I'm a trunk, will you be a trunk? It's negotiating. Now, what protocol is used in negotiation? .1q. .1q protocol. It can also be called as IEEE 802.1q. So now this IEEE 802.1q protocol is negotiating. Because of negotiation, operationally it becomes trunk. Administratively it is auto, but operationally it is trunk because of negotiation. I would like to show you this before we move further. We are back to this lab and I'm going to switch one. I would like to call this as switch one. Create VLAN 10. Name sales. VLAN 20. Name production. And then interface F01. This is this port. 1 minute, I want to make it a switch one. So this F01 should be VLAN 10. F02, I want F02 to be VLAN 20. So administratively, I'm configuring it as access port. So operationally also it has to do access only. By giving this command, I'm just changing the administrative mode from auto to access. Auto to access. So operationally it will be access. And it's a member of VLAN 10. Now let's go to the next interface F02. You see, before I configure anything, I want to show you once. Show interface F0/2 switch port. You see, administratively, it is auto. Now, if I'll go to and say switch port mode access, I'm changing that auto to access. Let's go verify now. You see, I changed the administrative mode. from auto to access. See, I'm the administrator, right? I am the administrator of this router. So whatever I configure is the administrative mode. Now, let's put this interface in VLAN 20 because right now it is in the default VLAN 1. So interface F0/2 switchboard access VLAN 20. Let's verify show VLAN brief. We can see F01 in VLAN 10, F02 in VLAN 20. All right. Okay. What is next? I'm going to do similar configuration on next switch. I'll go to switch 2 and say host name switch 2 interface F01. Oops, I forgot to create VLAN. Is that okay? Yes. Correct. When we configure VLAN on the interface, it will create automatically. So I'm going to make use of that and say switchboard mode access switchboard access VLAN 10. And the other one interface F0/2 switchboard mode access switchboard access VLAN 20. Done. Now what is next? The next is verification. Show VLAN brief. Now is the important place. We are going to make this F04 as a trunk. Let me bring the picture here. We are going to make this F04 as trunk. By default, this is also auto. This is also auto. Definitely, it will not be trunking. Let's go verify that. We did not configure anything on F04. So which is then only a default setting. At this condition, when I say show interface trunk, no trunking. Likewise, if I go to switch to when I go to switch to and say show interface trunk, I see nothing. I see no trunking. Okay, there is no trunking. Now I'll go to this end. Listen, this end only, left hand side. Switch 1. Interface F0/1. Sorry, 0/4. Switchboard mode trunk. What I'm doing, I'm administratively configuring the access into, configuring the auto into trunk. I'm changing the auto to trunk. If I administratively make the trunk, it has got no other option rather than forming a trunk. So now if you type this command show interface F0/4 or switchboard, you will see because you configured administratively trunk, operationally I have no other option rather than becoming a trunk. And the encapsulation protocol working on it is .1q, .1q. We call this as on mode. I would like to show you that also. When we configure administratively trunk, how the trunking happens? Is it through negotiation? No. You see, show interface trunk. The mode is not auto, the mode is on. When you configure the port to be trunk, it's no more auto mode. The port is no more in an auto mode. It is turned on with trunk. So it says very clearly that this port is trunking right now. It also has got this protocol, but this protocol is not the reason for trunking. It is .1q. Sorry, it is on mode. You on it. The .1q is not the reason for this particular port to be a trunk port. You have turned on. But this encapsulation protocol will go to the other end of the wire. It will go to this wire. You have turned on here only. It will go to this wire. Who is going? Other end of the wire. .1q. .1q goes to the other end and negotiates. And this port, because it is an auto administratively and access by operation, as soon as the negotiation comes, it agrees to form trunk operationally. Administratively still auto. Let's go verify that. I'll take you to the next switch, the right hand side switch. This is already trunking. I want to show you. When I was typing this command before, it was not trunking, but now it's saying trunking. How? Negotiation. Negotiation of .1q. And the mode is what? Auto. This N stands for that negotiation that happened. Whereas on this switch where we configured trunk, you don't see an N because it is turned on. We see N here and auto here. That's the reason for this trunking here. Okay. Now the port number is F04, which is trunking. So when you type show VLAN brief, you will not find F04 in the list. Any trunking port will be invisible in this VLAN database. It won't be shown in the VLAN database. So we don't have F04 anywhere. But this F01, sorry, this F04, though it is not listed in VLAN database, it is a part of all the available VLANs. It is ready to allow traffic of all VLANs. At present, we have only these three VLANs. Okay. Now we learned about trunk negotiation protocol called .1q. What is next? We want to see the dynamic desirable. What is dynamic desirable? After that, we'll get into that topic of inter-VLAN routing. By default, operationally access administratively auto. By default, administratively auto, operationally access. Okay, now we want this link to become trunk on a condition. What condition? Condition is this port when I configure as dynamic desirable, it cannot immediately form trunk. The condition is to form trunk, the opposite side should agree. Listen carefully. Only when this side agrees, this axis will be changed into trunk. The other end of the wire should agree. By default, you have auto here. So when you configure dynamic desirable, the negotiation will go. First, the negotiation will go. This will not form trunk. It will go first to the other end. Negotiate. If this guy agrees to form a trunk, the reply will come. Then this becomes trunk. You got it? Now, what is the difference between on mode and this? When we on trunk, immediately this becomes trunk. And if this is not auto, operationally, it will be access only. Now, here you configure trunk. This is coming and negotiating, asking whether we can become a trunk. But switch 2 won't agree. Why? Switch 2 administratively it is access. Switch 2 won't agree to form a trunk. But this side is already trunk, which is very bad. This side is trunk, but other side is not trunk. So is this link a trunk link? No. This side thinks that I can send all VLAN, but this side is not accepting all VLAN. That will cause problem in the network. That is why dynamic desirable is needed so that it will operationally make trunk after checking with the other end. For example, when you configure dynamic desirable, administratively you configure dynamic desirable. Operationally it will be access initially, and it will go to the other side and say, hey, I want to form a trunk. Will other side agree? No. If other side don't agree, the condition is failing, right? So when the condition fails, this cannot form trunk. This will continue access. For this to turn to trunk, for this to become trunk, the other side should agree. You got it? Only after the approval of other side, this side can become trunk. I would like to repeat again. See, this link is not a trunk link now because by default, administratively, hmm, yeah, sure. Administratively, operationally. Administratively, by default, this side is auto. Operationally, access. Whereas this side I have made administratively dynamic, desirable. So what will be operational mode? Initially access. Initially access. But negotiation will go asking to support for trunking. And this switch to agrees because this is an auto, it will agree to become a trunk. So it changes to trunk. Because it is changing to trunk, now the response comes, yes, I am forming trunk as you requested. I'm ready for the trunk. After the response comes, this axis will be turned to trunk. See, only after successful negotiation with the other end, this end becomes trunk, not immediately. As soon as I put dynamic desirable, it is not forming trunk. It goes and checks whether other end is also ready for trunk. See, if this link need to be a trunk link, both sides should agree, no? Both sides should agree. If one side trunk and another side axis, that link cannot be a trunk link. So, dynamic desirable is doing this. When you configure when you configure dynamic desirable, immediately it is not operationally making it as trunk. It is not making it as trunk immediately. It goes and checks the other side, whether other side is ready to form trunk, ready to support trunk. If other side is available, then this side becomes trunk. If in case the other side is axis, you see, other side is axis administratively. So operationally also axis. In this condition, when you configure dynamic desirable, initially it will be axis and negotiating what? Trunk. But the other side is not supportive, non-supportive. It says no, I cannot support trunk. So the trunk link will not come. So the first switch is still continuing as axis because the other side is not ready for trunk. See, on condition only it forms trunk, dynamic desirable. Dynamic desirable, see the word, dynamically it forms trunk. Dynamically It wants to form trunk. That is why desire. That is, it wants. Let's do this and see. Now, I'll go shut down those ports. Or there is one command, default interface F04. This will remove all the configuration and set it to default. I'll do the same thing on other switch. Default interface F0/4. Okay. Now if you type show interface trunk, there is no trunk. Show interface trunk, no trunk. You're going to configure dynamic desirable on one side, and the other side is auto. Now I'm going to say switch port mode dynamic desirable. The other side is auto. Let's go verify now. Show interface F0/4 switch port. You see, I have configured dynamic desirable. Now it is trunking. It is because of negotiation. The other side agreed. Let's go to the other side and check. Show interface F0/4 switch port. See, it is auto, but it has agreed to form a trunk. That's why the first switch is trunking there. Now let us verify. Show interface trunk. Look at this. This side, negotiation, auto, but I keep see the first switch. On the first switch, we configure dynamic desirable. Yeah, and we want to see the mode. Show interface trunk. Desirable, not auto, it is desirable. But this is also negotiation, you see. Only on the negotiation condition, this is trunking. Did you understand? Let us do this inter-VLAN routing, which we did in the previous class. In the previous class, we configured an IP address 10.0.0.1 here, 20.0.0.1 here, 10.0.0.2 here, 20.0.0.2 here. If A wants to talk to B, this trunk link will take it. How? When I ping from here, 10.0.0.2, the traffic goes to this port, F01. F01 is in which VLAN? VLAN 10. And now it looks into the routing table, MAC table. MAC table says if you want to go to 10.0.0.2, you should go via this F04 trunk link. So what switch will do, when it is about to send out, the trunk port says, wait, I want you to tag. So it takes your packet, decapsulate and in the layer 2, it adds the tag value. What is the tag value? 10. VLAN 10. And now this traffic goes here with VLAN 10. Upon receiving, the trunk port understands that this traffic belongs to VLAN 10. So it removes that VLAN ID and pushes the traffic here down to the VLAN 10 members. By looking into the MAC address, it will know who is connected where in VLAN 10. So this is another job of .1 queue. First job we saw, it negotiates. The second job is tagging. Yeah. Tagging and tagging happens in the trunk port. The sending side tags and sends, the receiving side untags. That is a very important job of a trunk port. So if someone is asking what is the job of trunk port, tagging the traffic before sending, untagging the traffic on receiving side. Okay, next. In case if A is talking to B, can A talk to B through switch? Not possible. Why? A is in 10, B is in 20. So A will not send the traffic out if it do not know the router's address. A want to know the address of the router. A wants to know the address of the router. Why? Only router can route traffic between 10 and 20. You see, every port of a router is part of different broadcast domain. This is one broadcast domain. This is one broadcast domain. In another word, each port of the router belong to different local area network. One local area network is one broadcast domain. One VLAN is what? One VLAN is one broadcast domain. One VLAN is one broadcast domain. One LAN is one broadcast domain. Now, router is to connect between multiple broadcast domain because routers, each port is a part of one broadcast domain, one network. In router, you cannot have two ports with same network. Each port is a member of different network in router. Every port should be in different network. That is the another explanation of each port has got a broadcast domain. Okay, which means the IP address that I should give on G00, sorry, yeah, correct, this is G00. On G00, I should give an IP address 10.0.0, let's say 10 as a gateway. If this port is VLAN 10. Yes, for all VLAN 10, I want this to be the gateway. So here also I'll configure 10.0.0.10. And if this is 20 VLAN, this F03 is VLAN 20, then I need to provide an IP address starting with 20, and that becomes the gateway for this PCs. Okay, now we can see here there are two networks. Wants to communicate. We need a router, and router also part of two networks, 10 and 20. Now listen carefully. You are pinging from 10.0.0.1 to 20.0.0.2. How will the traffic go? This PC will send the traffic to the gateway, which is this path. It is sending to the gateway. Now gateway will read this destination 20. So the router understands that I need to push the packet this way. It goes here. And now what is the destination 20002? It delivered here. Is this part clear? Now let us change the scenario a bit. This time it is 20001. 20001 is the destination. So again, the traffic will go to the gateway like this. It goes to the gateway. Gateway says to go to 20, you should go this way. And switch says 20001 is this way. So it takes trunk and delivers here. You understand? The switch will ask to take a left turn. So before sending the traffic out, this will tag with VLAN 20. The traffic will come here with VLAN 20 and untagged and then sent here down as a packet. Did you understand this part? Very nice. Now this is not a practical way of doing inter-VLAN routing. In the real world, we don't do this. Why? Because we have given a separate port, this one and this one, for each VLAN. I have two VLANs, two ports I have given. But what if I have 10 VLANs? Will you be able to give 10 ports of a router? Not possible. Because most of the switches, most of the routers don't have 10 ports. Then what do we do? What do we do? What do we do? We don't give like this a dedicated port. Instead, we give only one port. For any number of VLAN, we have only one link. One port is enough actually. It is a gig port, gig Ethernet. This gig Ethernet is 10 times faster than this fast Ethernet. So why you need to provide a dedicated link for each VLAN? Not needed. We can take this one port, subdivide. That is what called a sub interface. We are going to subdivide this one physical port into multiple ports. We are going to subdivide this one physical port into multiple ports. And to each sub interface, we'll give different gateway address. So each sub interface will act as a gateway for each VLAN. So we are going to create sub interface, a kind of virtualization. So I'm going to say G0/0/0 dot 10. You can give any number here. For VLAN 10, I'm just giving 10 to remember for which VLAN I have given. But if you want to give VLAN for VLAN 10 dot 1, no problem. You can give dot 1 also. This is not needed to match with the VLAN ID. Okay, there is no need for this to match with the VLAN ID, the 10. So now this interface G000.10, I'm going to give an IP address 10.00.10. This is 10.0.0.1. Gateway is 10.0.0.10. 10.0.0.1, 10.0.0.10. And to the other subinterface, G0/0/0.20, I'm going to give 20.0.0.10. So here the IP address is 20.0.0.2.10, 20.0.0.1, 20.0.0.10. You see two gateway on one physical interface, but two sub-interface. We call this as router on a stick. We call it as router on a stick. Router on a stick. Up to here, please ask me question. You understood? Yeah. We give each sub-interface to each network as a gateway. Very well said. Okay, what is next? The important point is this port. You see, this port needs to now bring VLAN 10 like this and send VLAN 20 like this. It's the same port. Physically, it is one wire and one port. So this port need to be trunk now. In the previous case, not both the VLANs coming on the same port. It was not coming on the same port. It was coming from the left VLAN 10 going to the right VLAN 20. But now we got only one physical port. That's a member of VLAN 10 and 20 on the router side. On the router side, it is a member of more than one VLAN, which means on the switch side, we must configure trunk. Did you understand this part? Now for these PCs, I'm going to give gateway 10.0.0.10. This is what I'm going to configure on the router. This is 20.0.0.10. Here 10.0.0.10. And in here 20.0.0.10. Let's begin by configuring the PCs. PCs don't have an IP address as of now. 10.0.0.1, 10.0.0.10. Done. You may verify by typing the command ipconfig. You see 10.0.0.1, 10.0.0.10. Likewise, the next PC 20.0.0.1, 20.0.0.10. 20.0.0.1, 20.0.0.10. 10.0.0.2, 10.0.0.10. Next, this one. 20.0.0.2, 20.0.0.10. All right. I have finished configuring IP addresses. Now, let me go check whether this F03 is a trunk. Show VLAN brief. F03 is not trunking as of now. F04 is trunking. You see 4 is missing between 3 and 5. But we want 3 also to trunk because 3 is connecting to the router. I'll go to F03. Switchboard mode trunk. That's it. Show VLAN brief. But still 3 is there. The reason is it is not active. Why? Because the router port is shut down. When you say no shutdown here it will become green. If port on a switch need to become active, the line protocol should come up. The line protocol is shut down here. Let's go to router 1. Sorry. And enable config T interface G000 no shut. See, as soon as you say no shut, on the other side, F03 will start. See, line protocol has come up. This F03 will disappear from here, you see. Yeah, it has disappeared because it is right now trunking. Show interface trunk now. You can see F03 is on. We have turned on the trunk. Next, going to the router side to create sub interface. Right now, show IP interface brief. You don't see any sub interface, just got G000. This is what I'm going to subdivide into 2. How? Like this. Hey, we give a host name. Let's give a host name. I would like to call it as inter VLAN router. Just some name. Next, interface G000. See, it should be in a no shut state. It should be up. Okay. When you do this, it should be up. So I say no shut. And then I go out and I say .10. See, for VLAN 10, I am putting 10, but it is not mandatory. You can put 1 also, as I said earlier. Okay, now it is creating the sub interface. And because the physical interface is up, so sub interface will automatically come up. No need to say no shutdown for the sub interface because we only created it. Next is, we cannot give IP address directly. It won't accept this command, you see. We cannot give directly because it's a sub interface. You should know, the router should know to which VLAN this belongs to. Because the router knows that I'm connected to a switch on the other side if there is a sub interface. Router knows that I'm connected to a switch and that side is trunk. How it knows? Because it is not one, it is 2 interface on 1. 2 sub interface on 1 physical interface. So it knows that on the other side definitely it will be a trunk, so we need to know what VLAN belong to. So this is the command. Encapsulation using .1q VLAN 10. So we say this sub interface belong to VLAN 10. Only when you do this, the 10 tagged traffic. See, on the switch side, it will be sending tagged traffic, right? When I ping from here, this trunk port will send with the tag. So router will know that it belongs to this sub interface. by looking into the tag. Now put the gateway, it accepts the gateway. Now come out of this, again create another sub interface, encapsulation.1q20, and then put the IP address. That's it. We'll verify now. Show VLAN brief. Show IP interface brief. You can see two gateway address assigned to sub interface, which is a member of single interface. Show IP route. I should see route 10 and 20. From here, I'll be able to ping all the computers 10, 0, 0, 1. This is router, no? It is in the center. So I can ping all the VLAN members. Yeah, I can ping from here, but pinging from this PC to this PC or pinging from this PC to this PC will take long route. I repeat. If I'll ping from here to here, will it go through the router? No. It'll go through the trunk link like this, straight. Do you agree? Same VLAN member. Likewise, if I ping from this PC to this PC also, it's the same trunk, correct? Okay, but if I'll ping from this one to this one, what will happen? Traffic will go to the gateway via first sub interface and then come via another sub interface. While going, it will go as VLAN 10. While coming, it will come as VLAN 20 and get delivered here. So who is changing this tag, Router. You remember we gave sub-interface VLAN tags. So router knows that while sending out sub-interface G0020, I have to put tag 20. So it removes VLAN 10 coming traffic and swaps it with the VLAN 20 and sends us VLAN 20 traffic out on the sub-interface. So F03 receives with the tag 20. That's why it is delivering to F02 where we have 20. Do you agree this? It goes to 10.00.10 and then comes back to 20.0.0.1. I want to trace route and show you this. If I go here and say trace, T-R-A-C-E-R-T, that's the spelling Windows use, T-R-A-C-E-R-T, trace route 20.0.0.2, no, sorry, 1. You see, it goes to the gateway first, take a U-turn and come. While going to the gateway, it will go as VLAN 10. While coming, it will come as VLAN 20 from the gateway. And switch will untag and send it to VLAN, to the PC without any VLAN tags. Now, if I will ping from this PC to this PC, it will go here, take the VLAN 10 sub interface, come out as VLAN 20, And the switch will say you need to take a trunk. So this will again tag, go like this, and then goes here. This is a long process. You see, packet goes here, processed here, goes down, processed here, comes up, processed here, goes like this, processed here, and then goes down. Too many motherboard processing. Let's trace route. Not from here, from here. Trace 20002. You see, 100010, it goes to the gateway and then goes to 20002. Looks similar, but number of motherboards processed for 20002 is more than 20001. For 20001, it went like this, two motherboard, and then third motherboard came back. So you go like this, first motherboard processed, go down, second motherboard processed, come up, third motherboard processed, and sent here. Whereas in this case, between this one and A and D, first processed here, again processed here, again processed here, again processed here, and then delivered. You say you understand? You agree? You understand? What do we call this method as? I know intervalent routing. What is this method? The previous one is also intervalent routing. What is this specifically called as? Router on a stick. See, we have one more router. We have one more method of doing intervalent routing, that is using multi-layer switch. In that, we will create SVIs. SVIs are nothing but switched virtual interface. That's a routed layer 3 interface for VLAN. But to do that, we need a multi-layer switch. In our next class, we are going to start with that.